pleasure to host you. So we're really looking forward to hearing your presentation as well. So the stage is yours.
Thank you very much, Onurcan, and thank you for organizing this event. It's always quite exciting and enjoyable for me to talk with the social scientists and young social science students, because what I really believe is like the computational social science requires such domain specific expertise and the type of problems that you can ask, and with your capabilities in programming and data analytics, like there will be more you can contribute in computational social science. So when we were chatting initially with you, I promised a talk that is about data science plus computational social science, try to give my perspective on as a data scientist. So my name is Onur, first of all, and I am a faculty member at Sabancı University's computer science program. And later I will also talk about a little bit of my background, but what I do in my research is using online data to solve societal problems that may come from various different disciplines. That's what motivates me in doing research. And I would like to just give like this well-known definition of computational social science from this science article by David Lazar. But what I really like a definition from the Matt Salganik. So I think the computational science is really doing anything that is cool, and that's what I try to do in my research, and I recommend everyone to do it. And being a specialist, sometimes it is much more easier than coming from a computer science background, because I can only learn so much that is an interest to me. But I can contribute some tools and methodologies to this field. So I think that's also an important aspect. And one thing that I can say from a data science or more computational perspective is like, if there's a valuable data, we try to see an opportunity. We try to look for a question and try to craft hypotheses from these data, and then build our own narratives and stories that kind of like shape data into a story. But I think one of the most exciting computational social science problems and research is coming from when you have an hypothesis and questions, and then you bring your own data, gather your own data to answer those questions. And with a social science background, that's what you can really do. And that's, I think, what is so important. And of course, there's like nowadays various different data sources. We have been talking about social media, how we can utilize social media for different problems. There are knowledge bases, people are contributing, and it's growing to an immense size. So there's lots of valuable data in those platforms. We can use search engine in a way to kind of quantify and monitors people's interest and how it changes over time. Or we can go and reuse some other data created and collected by academics from different platforms. And I think one of the most creative way of addressing such problems is like really doing your own data creation process. You can collect data for research purposes. You can gamify your tasks in order to gather such data. Nowadays, like there are lots of gamifications of fake news detection, misinformation detection. And I think it's both engaging and it's also creating digital media literacy to understand about these problems through these ways. Or you can collect data where people are logging their experiences, and these data sometimes surprisingly reflect their online and offline life, and bring answers to various different questions from medical sciences to mental health. So that's why I try to kind of like build my lab, viral lab, around different problems. And because of my background and research interest, I have been studying detection of social bots and manipulative entities in social media in general. We are looking at a problem of misinformation and online manipulation. And I'm interested in mental health and well-being aspect and how we can study those issues using online data. And recently, I've been doing a research on science of science, so where we can bring academic knowledge or information from different fields to answer science-related questions, how we conduct science, or try to forecast what might be the feature in science. So as we were initially talking, I promised Onurcan a different presentation, not to repeat myself with my old work. So there are some nice videos where we kind of like cover different research aspects in the past. So I'm just putting them out there. But I wanted to give in this presentation at least different fields and what really motivates us to address this problem. And I'm really hoping you can connect with your expertise to those problems, and there might bring a future opportunities for collaboration. That might be your thesis subjects and so on. So I think these are my list of exciting questions in the field. So for instance, in detection of social bots, what I've been doing is developing social bot detection models. We are currently also using deep learning for text, image, and network analysis. I developed a system called Botometer. That was also a platform where you can get an automation score for a social media user on Twitter. And any system have their advantages and disadvantages. So nowadays we are also looking different bot detection tools and systems and try to quantify their biases. For instance, evaluating political bots. And so far, most of the bot detection systems focused on the text and the network aspect or user metadata aspect, but we are not really tagging into the valuable information in the images. So one of my students building a social bot detection, automation detection system on Instagram, but the way he's developing this platform is it can be a general usage. So in one scenario, it can be an Instagram, but we can easily transfer it to a TikTok or other venues. And I think one of the most exciting questions, like how we can understand developing social bots in a simulated social network through adversarial learning, because many of these approaches are try to be proactive. We try to foresee and understand what might be the next threats, but we can only collect training data in the means of like when we identify different social bots. So generalizability is an important issue. We need to have systems that can perform well in a new emerging threats as well. And I think that's going to be an important direction in the next 5 years in that area. So similarly, we have been looking at infodemics. So we are collaborating with Tate.org to understand like how vaccine misinformation spread in Turkey in the past 1.5 years. And we structured this problem into an actor mechanisms and audience model. So what actors means, these are the creators of disinformation and what type of content they create for vaccine misinformation. The audience are actually the people who consumed that information and in a way contribute to this spread of these information. So we wanted to understand who are the vulnerable individuals, because in the United States example, vaccine hesitancy is highly correlated with political leaning. In Turkey, luckily, we don't see such patterns, but we still want to understand what distinguishes a vaccine supporter from a vaccine anti-vaccine community. So we try to understand the factors affecting their beliefs in vaccines, and how we can build systems for coordinated activities as well. We have an upcoming election in short or maybe in a couple of years frame, and we want to be ready for any coordinated activities that are a threat for the election process. And we have been studying political parties, their networks, their communications as well in these processes. And for science of science, it's a really recently emerging trend, a field. And people have been always wondering like what determines success. And really, when we think about success, it's not much about like what you can do, it's about how people perceive you. So what you can do is more about your performance. You can work harder. If you're an athlete, you can run faster. But distinguishing a top football player from others, of course, there's a talent involved, but some of them is how people are perceiving you is also an important concept. And we are also looking how we can leverage academic networks and information extracted from these publications to define metrics for online success, because in many cases, citation numbers, H indexes are only a weak indicators of academic success. So we wanted to understand the factors playing a role in people's careers, the environment that are nurturing them, and how we can really put a methodology behind those questions. And for the mental health, we are looking at from the lens of online data mostly. We wanted to understand how we can estimate mental health and well-being states. And we are building causal models that are commonly used in econometrics to detect determinants of healthy behavior. And we also understand the factors really tapping into people's well-being and influence their well-being. So if we go a little bit back, so what I done so far for studying misinformation on social media, I am a big fan of like building instruments. So I built Botometer later used in Hoxie and BotSlayer. So these are really bringing opportunities for social scientists and journalists and even citizens to study their online social networks to understand these problematic content and entities. And when we have once we have these tools, then we can start asking different questions. We can define our scope on and ask like, what's the prevalence of social bots in social media? That's one of the questions I answered once I developed the Botometer. That was the first one. And then we look for the competition among different entities. We look for the US presidential election and try to understand like what are the social bot strategies to manipulate people. And another important concept is amplification. We try to understand like how misinformation is spreading, what is the role of the gatekeeper, for instance, journalists, in that process. And we look for different topics and audiences. Like, as I say, vulnerability is one of the crucial components to understand the audience aspects. And the information gatekeepers is also another important one, which we had a paper on, looking at like their social network composition, how much social bot journalists have, and can we identify anomalies in their followers. And of course, looking for election cycles. And since we were talking about social bots, let's kind of like give some definitions and what they may have, what they might be causing as a problem. So we know like social bots can cause and manipulate stock markets. We saw examples of like political smearing, astroturfing campaigns. Nowadays, it's not really surprising if someone says this particular politician purchasing bot followers. But I think nowadays, these type of scenarios evolved quite interestingly. So observing a social bot from someone's follower base doesn't necessarily means this account is purchasing all these bot accounts. And there's an interesting scenarios one can imagine in that systems. And nowadays, it's also not really surprising to see social bots used for marketing, spamming, or social pollution. But what really concerns me is their impact on people's mood and behavior, because these are really hard to identify, but have huge consequences. And I really like to motivate from this review article by Stefano Cresci. So he has been looking different articles published in the past maybe 10, 20 years to look for use of automation manipulation on social media for different electoral systems. So he pointed out like 39 different countries and the publications that is supporting some indications of manipulation. And he has been also looking at this field of like social bot detection and how rapidly it has been growing. So there are some key papers and the field is still in the phase of like developing and growing. So luckily I was the part of the paper number 3 and paper number 4 and have a chance to see this field in a really early stages. And in that field, there might have different definitions of social bots. And my definition is social bots are not a problem that we can classify as a binary problem. So there's not an easy to say this account is 100% automated or this account is 100% human. I think it's a spectrum, and we see lots of evidence for that to be the case. So there are lots of gray areas. Accounts might be controlled by mainly humans, but using some automation tools, or accounts that has lots of automation tools, but people are kind of like from time to time coming and nudging the systems. And even at some point, my account was using an automation in social network curation, recommending me who to follow and such. So in that sense, my network automation happened in my account as well. And in order to understand these different mechanisms of automation, I developed a system called Botometer. And Botometer evolved a lot in the past 5 years. So we had different versions of Botometer, try to keep up with the game of this arms race between bot creators and bot detectors. So in that system, you can plug in your Twitter account or any Twitter accounts handle, and then you can check a score for a bot for a social media account, and that score indicates how likely account being a social bot or human. And in my case, it's a low scores indicating that my profile acts mostly as human. And in the earlier cases, we also wanted to make sure this tool is really accessible. So in the past 5 years, Botometer have 4 major versions. In the first one, we use and utilize already existing data sets annotated by other researchers. And we created our social bot detection platform and released our first public API. And in the later paper, we incorporated more annotated data that we collected and labeled. And at that time, I did a social bot prevalence study and estimated 9 to 15% of active English-speaking social media accounts being social bots. And it's a funny story. When we published that results in 2017, Twitter was releasing a 5% estimate to their own investors, and many people seeing this as a high estimate. But just in 4 or 5 months later of our publication, Twitter became more proactive in deleting and suspending social bot accounts because it was ISIS trying to recruit for their extremist campaigns. So just in these 4 or 5 month periods, Twitter actually deleted over 60 million accounts, which is corresponding to pretty much 9 to 15% our estimation range. So it's kind of like seeing an external validity when Twitter becoming more proactive in deleting those accounts. And later on, we kind of like started to see evolving social bots, different methodologies bots have been using. So we incorporated these as features in our learning system. We use different annotated data set. We updated our features because Twitter is changing their API from time to time. So for instance, the time zone feature or the coordinates become less available in Twitter platform. So we need to adjust to those changes. And one of the PhD students that I work with see an opportunity to creating a lightweighted model of a botometer, because botometer has some limitations. So it's the rate limits of Twitter is slowing some of the analysis down. We cannot work with the deleted or historical data because we need to make a request to Twitter and collect data in order to get a botometer score. So Kevin did a lightweighted botometer, which can work only with the user profile metadata. So the performance is not as high as Botometer, but it's a great trade-off considering the speed is increased almost 1,000-fold, and it can work with the deleted data. So it's a great alternative method for large-scale analysis or filtering data from social bot. And recently, we changed the Botometer machine learning architecture and redo it from scratch. So what we did was, previously we had an ensemble model, try to learn using various different features, whether some account is social bot or human. But in this past 5 years, what we realized is there is no single type of bot. There are various different types of bots. And in order to have a more generalizable model, we need to understand behaviors of these bots using different models. So we had these individualistic bot detection model trained on different bot classes, and then ensemble of these bring and improve the recall and out of domain performance significantly. So currently the Botometer is utilizing this new architecture as well. And having such a system, we can conduct large scale analysis, and this is still one of the largest study done on social bot research on Twitter, because Twitter API become much harder to collect data. But at that time, I had an opportunity to collect social network structures of a 14 million Twitter account, getting their entire profile history. So I could ask various different interesting questions. I could ask and estimate what's the prevalence of bot likely population on Twitter. We study information flow between these different entities. We characterize social connectivity, and we try to understand different behavioral clusters, indicating that there's no one type of bots in our data. So by looking at models with different sensitivity to social bots, we made our estimates of 9 to 15% of accounts being automated. And another important aspects, and I think to to me, important contribution to computational social science is try to release these methods, these data and APIs publicly. So with that, a political science student can use Botometer, an economist can use Botometer, and various different fields without any computer science background be able to study social bots for their own research problems. And we are still continuing to improve and further develop those systems. And luckily, this system is well received. So this is a little bit outdated figure, but in any day nowadays, we receive at least 500,000 requests to Botometer API. If there's an election cycle, these numbers can go up to 1 million requests per day or over. And this is quite exciting for us to see such popularity. And this was like one of the focuses of my lab, looking for social bots, manipulation, and online system. But another one that I really value and care about is how we can study mental health and well-being. And I'm choosing my research problem based on my own interest. So really the point of doing a research is answering the questions that you want an answer. So I try to read more on these subjects and try to understand what I can bring to the table. I look for collaborators that can answer my silly questions, because those are domain experts, but I'm only and computer scientists try to offer some methodologies to them. So one of the problems that we recently studied is a concept called effect labeling. So it's a well-known phenomenon in psychology. So you may have heard, like in therapies or other applications, if you have a bad feeling, if you have a depression and try to seeking for treatment, there has been this saying, like putting these feelings into words, like writing it down, speaking it out is therapeutic effects. And we try to understand if it is really the case. Can we understand the emotion regulation using social media data? And what we did was we look for Twitter, we look for I feel statements. So we look at tweets that says, I feel great, I feel amazing, or I feel sad, I feel terrible. So both positive and negative spectrum. And we identify those tweets and look for the language and align all these tweets at, let's say, time 0. And we analyze sentiment before and after these I feel statements, try to understand how positive and negative emotions are emerging and disappearing. And that gives us quite interesting results. So for instance, in positive emotions, there's a build-up time for about 1 hour. So when you say, I feel great, you actually already start feeling great about something in the past 1 hour. So your emotions are keep rising and rising. So when you hit this exhale point to the maximum peak, it suddenly started to die off and you return back to your normal self within an hour. So that's kind of like a pretty symmetric increase and decrease curve in your emotion balance. In the negative case was much more interesting and supporting the hypothesis that we have. So negative emotions started to emerge 2 hours before, when people are really hitting the bottom and say, I feel terrible or sad. But then the healing and returning back to the base level happens within half an hour. So that's really quite rapid changes. So venting out these emotions is really helping people to return to the base levels. And we validate these findings from different models, try to estimate the significant periods for those changes. We even see gender-based differences. So women are much better at venting those negative emotions than men in our analysis. And by using and tapping into these tools, I started to ask different questions. So this is my one of my Twitter projects. We are looking at the daylight saving, and I think this audience is quite familiar the consequences of having Turkish current daylight saving time. So these charts, you can see when the sun rises in your local time. So nowadays in Turkey, in the winter time, sun rises basically local time at 8 a.m. In summer, it is 5 a.m. and it's kind of like fluctuates around those. In any other country that you can see in Europe, they are applying daylight saving, and this, they adjusted when sun rises in their local time. And we can see these discontinuities are when the daylight saving happens. And the further you go to the north, you can see a more difference between north and south. You can see more difference between summer and winter time. So Turkey is one of the interesting case for me because after 2016, we stopped doing the daylight saving. But before that, we have a good examples of like using daylight saving time. Russia was another interesting example. So they were using daylight saving until 2012. They quitted, and then they say we continue not applying daylight saving, but we are going to switch the time zone. So they did that in 2015. So having such data, so I have a past 10 years data for Turkey and their social media messages, and we calculated the daily aggregate sentiments of the population. And we can ask questions like, what are the consequences of having daylight saving and not having daylight saving? So we can compare two different population. One is using daylight saving and the other is not. And we can study the consequences of not having daylight saving. And another interesting story, which could be the third panel for us, is the COVID period, because daylight saving creating a pressure on individuals because we have a social structure. So we need to be at work at certain time. We need to hit the road to be at work at certain time. But COVID is kind of like relaxed all these conditions. So people start working at home. Maybe they tend to wake up later. So there's no so much strict social structure, social clock. And we wanted to study separately the 2020 and later for that particular research. So we are studying 3 different population groups to answer the daylight saving time implications. And this was a preliminary study that I did for the US population. So we can study the valence changes for population after the daylight saving. And when I did that, one thing was quite interesting. So the Monday after the daylight saving, the morning hours are much sad than the previous week. So people wake up and complain more about the daylight saving on Monday. And then the negativity is kind of like return back to normal in 4 days pretty much. So people are adjusting to these daylight saving in a short time period. So we are currently seeing similar patterns in Turkey as well when they were applying daylight saving. But now we are trying to understand and build causal models to see if that's the case when we don't have a daylight saving, or through an entire winter period, how our overall well-being changed. And also study COVID period as well. And having aggregated sentiments of the population for a 10-year period also bring lots of other interesting opportunities for us, looking at the important societal events in Turkey. And I think that will be bring another research direction as well by looking at these societal changes. So what I try to do in my research is really bringing data sources from different venues. We look for mobility, social networks, knowledge networks, and try to answer questions about like sleep and daylight saving, mental health, and science of success, and so on. And in order to do that, what we really need to accomplish is being an interdisciplinary scientist, and we need to really manage and model these complicated systems to answer these interesting social science problems. And since Onurcan mentioned this audience will have social science students and this is their activity, I would also like to give my perspective, like how I became who I am right now, because my career is also like really take a strange path. So I enrolled to Istanbul Technical University as an electronics engineer. And I did physics double major at my time at Istanbul Technical University. This was the time I was quite excited about network science and complex systems. And that kind of like shaped all my career afterwards. So I did my master's degree at Koç University in CS. I studied how proteins are fluctuating, try to understand the complex systems in a biological system. Then I did my PhD at Indiana University in the field of informatics. And having an informatics PhD, then CS has quite advantages for me, to be honest, because I get to ask questions from that relates to different fields. So I collaborated with political scientists when we were studying election. I collaborated with psychologists when I wanted to understand the human behavior. We studied with journalists and experts in biology. So try to bring all these different experts from different disciplines to work together and collaborate on an ambitious and exciting problems for us. So I think computational social science is a field like that. So people from different expertise and knowledge can come together and really make an impact by asking hard and challenging questions. So I try to keep those practices in my group as well. So in our lab, my master's students are coming from computer science, finance, industrial engineering, statistics, history, international relations background. So I have also mechatronics, economics students, and they are mostly doing data science masters or political science masters. So we try to bring those interdisciplinary knowledge, expertises from different fields into our research problem. One of my students studying science of science bring his econometrics knowledge into the problem, or one of my finance students bring another tool sets to the problem. So I think that's what is really valuable. And when I see students try to learn computation when they are studying social science, that really excites me. And I think that's the most important aspects of computational social science. And I try to bring this, like maybe conclude with how I see science as a metaphor. So maybe you can take a second and think about, like, if you really wanted to put science into a three-dimensional shape, what would it be? So how you will think about science. And to me, it is gevrek, because I'm from Izmir, but some may call simit. And why I see it's gevrek is because when people are looking at co-citation patterns across different disciplines, you can see like some of the fields, let's say in blue, mostly engineering and computer sciences. When you look at the green one, it is mostly psychology, finance, econometrics. When you look at the orange, it is social sciences, behavioral sciences, and then the rest is medicine and others. But what really strikes me is this kind of like a circular shape. So certain disciplines are collaborating with each other because of their needs, but there's really rare studies that are trying to bridge across these different part of the maps, and I try to do that. And I also promise giving some recommended books, like Bit by Bit. I think every computational social science students should read it, and these are some other nice books that I find influential and exciting. So I would like to thank, and will be really happy to answer your questions.
Thank you very much, Hocam. And also another anecdote I'd like to share about science when the topic comes to it. I was watching the evolutionary biology classes from Sapolsky, and he says that we humans divide things to conquer them. When trying to find the meaning of life, we distributed to pieces, which became the disciplines of sciences. But he says that we then forgot to merge them together. So this is why I, directed to social sciences, computational social sciences. Are there any questions for Onur from the audience? I see a hand from Ipek, and then there is a question in the chat.
So should I read Gizem's questions, or would you like to read Onurcan?
I think Ipek raised her hand first. Would you like to?
Yeah, of course, of course. You are moderating, so I will be happy to answer any questions.
Okay.
Thank you so much for this talk. I am using Botometer for my research as well. So I have two questions. If it's possible to ask. Okay. So the first questions about bots. You mentioned that bots have high spectrum and that could be close to humans. So what I'm curious about, if I am person, citizen, and if I see a tweet, how I can identify complex bots? This is the first question. Yeah.
Would you like to ask both of them together, or you want me to
maybe
answer
this
one by
is
one?
yeah, because not unrelated.
Sure. Yeah. So when we were even doing the annotation, we tried to not give so much detailed tips for annotating, because we wanted to make sure people are using their own judgments when they are annotating. So we are giving some tips like in terms of automation. So there are some red flags. So if an account keep retweeting the same accounts, and that's basically the all of their behavior, that's sometimes suspicious. Or inconsistencies in the number of friends and follower ratio. So having thousands of friends and follower indicates sometimes bots are trying to grow their popularity by following and unfollowing other accounts. So sometimes it's a red flag. Or an account having thousands of followers, but all their content getting a pretty low engagement sometimes indicates like these are passive followers and doesn't really engage with the audience. Inconsistencies in the content, another one. So we see an example of like third-party application posting on behalf of accounts. So you may let a third-party account to use your account to follow or unfollow other accounts or retweet on behalf of you. So some of these third-party apps can be abused. And you may be 100% organic human using your social media for your own, but these third-party apps can go and follow accounts without you even notice them, or retweet content without you even notice them. When you are sleeping, they can go and retweet and make something a trending topic. And then before you even realize, they take their retweet back. But these spike of activity misleads some people, and people may tend to believe, okay, this is a popular content, maybe it's a factual truth, and they may believe. So there are various different of these red flags, and I think it's different for different type of bots communities. I always see a new way of manipulating Twitter, and that's always surprises me. Like in one cases, there was a campaign in US. So it was about Mexican immigration. So what they try to accomplish is really manipulating a letter in the hashtag, and bots are actively sharing a content on that hashtag, try to create a fake trend. And once people start paying attention to those trending topics, they were just seeing an irrelevant content, but real organic people discussing the issues, they go unnoticed. So that was like one trick that recently happened. So I think bot creators are creative in terms of like creating bot accounts, but as we bot detectors should also adapt and keep up the game and try to improve the systems. So that's why generalizability is quite an important aspect for Botometer.
Thank you for the answer. And my second question is, I find very interesting that you say when you investigate COVID-19 in Turkey, there is difference between from the US studies. This is also something that I am investigating for my PhD research, especially COVID-19 health misinformation. I also see that especially for the Czech 40 tweets are different among the communities, Turkish and Bulgarian and other nationalities. So what I would like to be interested in, what is your first observations on Turkish community? What is the biggest difference than the USA?
So definitely not so much political polarization in terms of like vaccine hesitancy. That was, I think, to me, a good news. But there are still some tendencies of people against vaccination, having this conspiratorial mindset. So I think conspiracy theory communities are driving the vaccine hesitancies, and we try to understand like who they are and what motivates them to share those disinformation. We are still investigating who are the audiences, who are the vulnerable people for those misinformation. So it's more challenging to kind of like estimate the education level or other covariates people may have. But we try to understand it from their content and the profiles to distinguish that. So one of my students, Özgür, is currently investigating that problem. And we are also getting help from Teyit to incorporate their insights as well, because they have some, they have an insight on like what might be the certain hypotheses they have been keep track of different disinformation also on Twitter. And we are hoping to identify those audience groups better in the maybe next month or so, and design a more proactive approach per group level. So just by fact-checking and disputing some belief about vaccine disinformation, unfortunately, it's not enough, because most of the conspiratorial mindset is not easy to change. Once they believe in one disinformation content, they tend to believe many others. So we try to take a more group-specific approach for that, but it's still an ongoing research, so I wish I could answer it in a more clear way.
Thank you so much for the answer.
Thank you. Thank you.
There are two more questions in chat. So the first one goes, what are the main obstacles to social media research in terms of your view? Do you think there should be some rules and norms for researchers in social media research? Who checks these studies' correctness or appropriateness in the end?
I mean, there's always the ethical aspect. So as researchers, we are kind of like a community, and we use our each other's research. So the value attributed by the academic community is kind of like a mechanisms governing those processes. And in terms of like getting access to social media data or obstacles in social media research, there's a great article that I was also contributing in HKS. So it's a Harvard's review journal. That's an online journal. So they asked several different social media researchers. I think it's kind of like having almost 20 authors. If you have an unlimited opportunities to work with social media data, let's say if there's a genie in a lamp, and if you can wish some data from them, what you will wish for. And to me, I wished for a better access, getting the dynamic nature of the social network, because on Twitter, we don't know when a certain individuals are following each other. So we can only see a static snapshot. That's one limitation, and we can benefit having such data. And the third one, and I think the most important one, having an access to the deletion information from an API. But because of the privacy and other constraints, they cannot really say what is deleted. But at least having a statistics of what is deleted is quite valuable, because systems like Botometer, they can only take a snapshot at a time. And we may see an account, let's say, having 1,000 tweets in the past 5 years. Maybe that's a normal when you compare it to a normal population. But we know an instances of those accounts, they post and delete, post and delete, post and delete, and they keep repeating that and creating these fake engagement and try to spread information. And it's a way of kind of like getting away from the detection tools. So social media platforms can also reveal statistics about deletion, because if an account existing with deleting content, that's not normal, and we need to be able to know that. So I think that could be one thing that I will really like to have.
Thank you, Hocam. The second question is, thank you for this insightful presentation, Onur Hocam. What advice would you give to a PhD student in social sciences who will be starting to learn CSS from scratch? Where to start? I think
everyone can give an answer from their own perspective. So there's no one answer to those. But what I try to recommend to my own student is having an interest at subject that really excites you is a good start. So you should pick a problem that you are quite fascinated and really wanted to work on, because in research, it's always ups and downs and ups and downs. So when you are in the down and the subject is really doesn't excite you, you are more likely to give up or say, okay, this is not a problem that is solvable. But if you are really persistent and want to know the answer, you keep try and learn and look from a different perspectives. So I think picking the subject is the most essential one, and then walking towards that goal path. So if you need to learn programming and coding, start doing it. It can be Python, it can be R, it can be tools that you learn from your own coursework. It can be Stata. So it's not really important what programming language it is. It's important what you can answer with those tools. If your project requires you to learn web scraping, go and watch a tutorial on web scraping and try to learn that. If your project requires doing a sentiment analysis, learn the packages, learn the methodologies available to those and apply that. So I've been learning new things every day as my projects are changing and evolving. So it's not an easy question. So there's not a, let's say, textbook that guides you all aspects of computational social science. So nowadays, most of my projects involve econometric tools. So I had a knowledge on causal models that I used in the past, but nowadays I need to learn more regression discontinuities, propensity score matching. So I sit down with textbooks and try to get a working knowledge on those methodologies. I recommend the same things for my students as well. So I think defining the scope of the problem, but of course, having some programming backgrounds, having some mathematical backgrounds, and the most importantly, having a knowledge on a specific field that you wanted to pursue is really important. And I think social science students are much more advantageous in that scenario. You take a 4-year education, maybe 2 years of masters to really study on political science, to really study on international relations or psychology. And when you start learning the programming, I kind of like really love social science students learning programming, because if the program doesn't work, it doesn't work, and you can always improve it. But when me as a computer science try to learn psychology, no one can say to me, no, you are saying it wrong. There's no compiler creating errors in my statements. So I guess going from another way around is much more challenging. So I kind of like to see working with social science students better, because they bring those expertise, and I try to catch up with them most of the time.
Thank you very much, Hocam. I have a question as well. Mary Hoca has a question as well. Mary Hocam, please go first.
Thank you. It's actually, rather than a question, it's more like a big thank you for both a really inspirational presentation, and also what you just said. I think it's really giving hope to social science students, because I mean, most of our students coming with no background in programming are actually really afraid of failing in learning it, and they always feel like they have a comparative disadvantage because they don't have any prior background. And so to say that when it's the other way around, it may be actually as challenging, if not more challenging, for your student, I think is actually really giving our students hope.
Absolutely.
So thank you for that.
Thank you, Mary Hocam. I mean, you are absolutely right. Students shouldn't afraid of learning programming if they are coming from social science background. So one thing we try to kind of get rid of is the disciplinary boundaries and mechanistical biases. So applying to a data science program sometimes hard for social science students, because the committees looking for some of these expertise because they need to be a TA in the courses and so on. But programs like computational social science master programs is venues like that. We try to have similar programs at Sabancı University as well. So one of my master students is actually from political science, but he learned Python programming. He is now doing network science analysis, and he knows a lot about international relations than I do. So he's kind of teaching me through the process, and I'm mostly helping him with the data science aspects of the thing. So I think we need more of these kind of guidance as well. So I definitely agree. So, and we need more programs that are interdisciplinary.
Absolutely, Hocam.
I'm going to digress from this topic a little bit, but I was just wondering if Botometer was ever used to determine the genuineness of a news, because we can, I think, hypothetically say that if a news is often retweeted by bots, then it would probably be a fake news.
Yeah, and that's kind of like bring back to tool building aspects of it. So when I created Botometer, it was always like a single account perspective. But then our team developed a platform called Hoxie, and Hoxie is using Botometer, and they are doing exactly the thing that you said. So in Hoxie, you can search for an hashtag, you can search for a URL, you can search for a phrase, and that platform goes Twitter, pulls most recent data, and look for the dissemination pattern, spreading pattern, and try to identify who are the key players and whether they are humans or social bots. And in many cases, when I see a trending topic in Turkey, I go and check with Hoxie and see if it's anything suspicious. Sometimes you see a social bot accounts being a really influential role in spreading that content, and many other bot accounts are retweeting or engaging with that content. So that's an indication of not the genuineness of an content, but it's whether it's a coordinated activity or not. So a news being a genuine is a much more challenging problem in the sense of require more text analysis and NLP and understanding of the content. And fake news detection researchers are more delving into that. So there's an aspect of like a research that looks and combines knowledge bases and try to verify automatic fact checking, applying automatic fact checking to verify all the claims in a text. So you can write a news article full of factual claims, but at the end you can put one paragraph of your own interpretation and blame others and or kind of like redirect certain claims, and that's also a problematic content. So in first draft is actually have a good way of like creating a taxonomy. So they have 6 different categories, and one of which of these categories are dealing with like how factual information can be repurposed in another context.
Thank you, Hocam. I don't think there are more questions. Thank you for spending your Sunday evening with us, Miri Hocam, Pınar Hocam, you
it's not
too.
spending at all. It was a well worth 1 hour, so I'm quite happy to be here sharing a little bit of my research and listening other hocams and their research.
We really appreciate it, Hocam. Thank you, and hope to see you next year as well.
Yeah, looking forward to this event next year.
Have a good one. See you all.